welcome to CEC lectures. Myself Dr. Preeti Chakani. I am from Department of Computer Science, Aribhat College, University of Delhi. So as you all are aware that in our previous lecture we have started a new series which is programming in Java, and we have taken the initial lecture in which we have seen what all are the features of Java and what actually it is. Now in order to continue with that, today we are going to take up a lecture on bytecode and platform independency, and this topic is also covered under overview of Java. Now when we talk about any programming language which is high level, so we code a particular program into that, and that is known as source code. Now in order in order to understand this source code, this machine needs to translate it, because our computer is actually something which is operating on binary language, and it is not going to understand the source code directly. So your source code, in order to be understood by the machine, needs to be converted into machine level language or machine language, we can say. Now who is going to perform this task? As we all are aware, is either it is interpreter or it is compiler. So I am taking compiler here. So compiler is something which is going to convert this high level language, which was we can say a high level programming language, into a format or into a form which is form of the program which is understood by the machines. Now when we talk about Java in terms of its we can say characteristics, one important characteristics which we we have stated in our previous lecture was that Java is architecture neutral, or we can also say that Java is platform independent. Now what do you mean by this platform, and how are we going to have this platform independency? So platform independency here in terms of Java, we can say that the compiled code or Java compiled code, which is known also known as bytecode, can run on all the operating system without any modification. So let us try to see and understand this topic of bytecode and platform independency. So when I am talking about the term platform, the platform means it is a hardware and software environment on which a program or application runs. Now what all is included in this the term platform? It could have the libraries, the operating system, other dependencies which are needed for the program to run. So basically platform is hardware and software environment on which a program or application is going to run. Now when I am talking about the platform independency, that means we need not to change the program according to the platform. That means the program which is being coded or which is being written for one particular platform will run onto another platform also without having significant without having any significant adjustments. So platform independence, what we can see is, or what we can tell is the ability of a programming language to run on different operating systems or different platforms, we can say, without having significant adjustment to be made, and this is what we call as platform independence. So basically this says that we are going to develop a code for, let's say, one particular operating system, assuming it Windows. It can be executed on another operating system such as Linux or any other without any kind of significant adjustments or without any problems. So this is what the term platform independence is. So platform independence is making a program independent of hardware architecture, making a program independent of operating system, or we can say making a program in a language which is a cross-platform language or which is an independent language. Independent language, that means it is not dependent on the platform, and cross-platform language, that means if we are going to make our program or if we are going to code our program for Linux, it will run on Windows and vice versa for other systems also. So this is what is here platform independency is, and as I have already mentioned that there is no need of significant recompilation or change in the program. So that means with almost very little, or we can say no coding modifications, program created in one platform, program created for one particular platform can be run on other variety of platforms, provided the language which you are going to use for coding that particular program is a platform independent language. Now, when we talk about platform independent language, what are the platform independent languages which are used nowadays? So here we can have JavaScript, we can have Python, then Java of course is a platform independent language, and all these languages actually includes libraries and frameworks that are going to make it easier to write a cross-platform software in these languages, whether it is Java or Python or C# or JavaScript. All these are platform independent languages. So these includes libraries and frameworks through which we can write cross-platform software. Another term which is used for platform independent code is managed code. So managed code is also the next term for the or another term for the platform independent code. Now, in a conventional language, conventional here means which is not platform independent, a compiler is going to convert the source code into the executable code, we can say, which we have just seen, and this executable code is actually sequence of machine instructions that can be executed by CPU directly. But when we talk about any platform independent language, this source code will be converted into an intermediate representation, and that intermediate representation of code will be interpreted by a virtual machine, and this intermediate representation in Java is known as Java bytecode. So basically what I am trying to say here is we are going to take one particular program which is written into Java, and an intermediate representation of that program will be created, and that intermediate representation is known as Java bytecode, and now that intermediate representation will be further taken or interpreted by a virtual machine. Now let us understand this whole process in a step by step manner. So whenever a program is written in Java, the Java C, which is the compiler of the Java, is going to compile that, and unlike non-conventional languages, the output of the compiler is not the executable code, but it is an intermediate code, and we call that code as bytecode, or we can call that as a class file also. So the result of the Java compiler is the class file, or we can say the bytecode. It is not the machine's native code, which is kind of a machine's which is actually an executable code which can be directly executed by the machine, and this is unlike our conventional C++ compilers. Now we have bytecode, which is the intermediate representation in a hand, and this bytecode generated is actually, I am repeating it again, it is a non-executable code. You cannot directly execute that bytecode. Why we cannot directly execute that bytecode? Because it needs an interpreter to execute on a machine. That means the bytecode, which is the compiled version of the code from given by Java C, will be interpreted by an entity, and then after that interpretation, the the output which will be generated after that will be we can say ready to be executed on a machine. So bytecode, and that interpreter here in case of Java is nothing but JVM, which is more commonly known as Java Virtual Machine, and JVM is a short form for that. So the interpreter which I am talking about is the JVM, and then that bytecode is executed by JVM, and then the finally that program runs in order to give the desired output. So I can say in between your source code and the executable code there is one more step in case of a platform independent language, and here I am specifically talking about Java, and that stage is nothing but we can say generation of the thing bytecode. So here you have a figure which is shown on the screen, and in this figure we can see that initially we have a Java code which is written in a .java file. We are going to compile this code using the Java C compiler, and after this Java C compiler, unlike the conventional languages, we are not going to have an exe which is going to be executed. Instead of that exe, we are going to have a byte code which is in the form of .class file. So for example, you have written first.java. So after compilation, there will be a class file named as first.class, and this class file is actually an intermediate code which is going to run on different platforms, we can say. So if there is a Java virtual machine which is attached to an operating system Windows, or there is a JVM which is attached to Unix, or there is a Java virtual machine JVM which is attached to Mac, these different JVMs are going to executed. So taking Java compilation through Java C, we are going to have an intermediate representation bytecode.class, and that class will be executed by various JVM. So this is what we can say the flow in case of Java goes on. So normally when we talk about the conventional languages like C or C++, which are not platform independent, the compiler is going to generate an .exe file, and that .exe file is nothing but operating system dependent. That program .exe file when generated for a Windows system will work on that Windows system particularly, and if it is generated for the Unix system, it will work on the Unix system. So we cannot say that that exe file is the platform independent thing. So when we are going to try this, when we are going to try to run this .exe file on another operating system, it will not run, because it is having some inner level details which are operating system independent, sorry, operating system dependent, and hence it is not compatible with any other operating system. So once if it is coded for Java, if it is coded for Windows, it will run for Windows only. So this is what we can say the actual conventional languages are doing, and instead here, or in comparison to these conventional languages, Java uses a virtual machine, and then the Java code which is compiled into bytecodes, these bytecodes are actually platform neutral. These are independent of any operating system, these are independent of any hardware architectures. So we can say that these bytecodes are the platform independent version of your Java code. And there is JVM, which is we can say inbuilt with machines, and that JVM is going to execute the uh, Java programs, and hence this platform independence is being achieved. Now this JVM is actually JVM interpreter, or we can say it could be in place of JVM interpreter. We can also see JIT compiler, which is just in time compiler, and that either the JVM is going to interpret or JIT is going to compile that bytecode, which is the intermediate representation, into machine code for operating system. And then Java, we can say, uses the JVM to compile the code once for all hardware architecture and operating system. So basically this is, we can say, is the magic of JVM, through which we can say the Java is going to attain platform independency. That means the programs written for Windows can be can be used on the Linux machine. So basically this virtual machine which I am talking about is this JVM. The virtual machine, this is going to bridge the bytecode, or this is going to establish a bridge between the bytecode and any machine. Any machine when I am talking about here must be a JVM compatible system. So on one side we have a JVM compatible system, on another side we have this bytecode. So it is the virtual machine who is going to bridge this gap, and because of this we have write code once, and it can be run on multiple platforms without having major changes, or without having we can say recompilation. So what is happening here? So this method is going to provide a consistent programming environment. Uh, Now how this consistent programming environment is being provided? That is by abstracting the hardware and the operating system both. So hardware and operating system both are being abstracted, and a consistent programming environment is being provided, and hence we can say these Java programs behave uniformly across the across various platforms. Now this Java virtual machine, which is JVM, is going to handle all we can say intricacies which are related to this platform independency. Basically it is going to handle all the hardware related details, and apart from this handling this hardware related details, now the programmer or the developer is somehow we can say relieved from platform specific compilation. Now platform specific compilation is not the we can say headache of the developer. So with the using of with the usage of JVM, it is also JVM is also going to handle all the hardware related details, and hence it is going to relieve the developer from platform specific compilation. And obviously because of these things the runtime requirements are being we can say reduced. So basically the Java virtual machine and the bytecode compilation combination lets the Java program run across the different operating system and hardware architectures, and hence it is kind of we can say turning into the simplification of the development. So this JVM, or the concept of bytecode compilation, is going to give the flexibility to run across operating systems and hardware architectures, and this flexibility is being provided to Java program, and hence the development of the program has become simplified, because now a developer is we can say relieved from all the worries of making the program platform independent, or taking care of making the program platform independent. Now when we come to specifically when we are going to talk about Java, or what are the steps which are going to convert, or in what are the steps through which a Java program can be executed completely. So before going into the execution, one term which we are going to be use which we are going to use very frequently is JDK. JDK is nothing but Java Development Kit. Now what all are the components of this Java Development Kit that we will be going that we will definitely go through, but let me mention here that this Java Development Kit, which is JDK, is sufficient to create any kind of powerful Java application. And JDK, when I am talking about as an entity, it contains some uh, components which are listed here. What are these components? These components are Java runtime environment, Then we have Java C, which is the compiler for compilation of programs. It will take the Java programs and turn them into or convert them into dot class files. Then we have Java virtual machine. Apart from that, we also have a document generator, and we also need some necessary library and tools. So JDK, when we talk about it, contains Java runtime environment, Java C compiler, Java virtual machine, the document generator, and other necessary library tools. Now, when we talk about this whole process of compilation and execution of a program, let's see specifically that how it is going to happen when we are writing a program in Java. So when we write a program, we save that with some extension, and in case of Java, we are going to save that program or save that program in a file, and that file will be named as the name .java extension, the extension of the file in which the code of Java is being stored is .java. Now this .java file is actually given to Java C compiler. Now what this Java C compiler is going to do, that it is going to compile that .java file, and after the compilation by Java C compiler, that .java extension file is converted into a .class file. Now after this step, so the first step was .java, that is the creation of the program, then the compilation, we are going to have .class file, and after this the JVM is going to execute, or we can say JVM is going to interpret the bytecode into the machine code, and hence we are going to get the desired output. So basically a very simple procedure of, we can say, 4 steps in which we are going to save the program with .java extension, compile it, convert the have the .class file, and then this .class file will be executed, or we can say will be interpreted, having a code which is machine code, and hence we are going to we can say have the desired output. Till this point in this lecture, what we have covered is, when we talk about the various features of Java, we have one very particular feature which makes it very different from other conventional high level languages, and that feature is nothing but the platform independency or architecture neutrality. So the platform independency says that the program which is written for one particular program, one particular platform, will be executed on other variety of platforms without any significant change. And we have also seen that how this platform independency is going to be achieved. So in order to achieve that, we have we can say a magic word or the buzzword of the Java, which is nothing but this .class file, and this .class file, which is having the bytecode, is generated by the compilation of .java file. So there was an initially .java file that is converted into Java .class file. There was initially a .java file that is converted into a .class file after getting compilation by Java C compiler, and then this .class file will be interpreted, or we can say executed, in the form of machine code, and hence we are going to get the output. So this was actually the platform independency or the architecture neutrality of Java, which we have just seen. Now when we talk about the paradigm in which the programming languages are working, so paradigm in which the programming languages are working can be your structured programming paradigm, or we have object oriented programming paradigm. So in our previous classes, or in our previous series of C++, We have seen object oriented programming paradigm also, and let me mention it here that in the heart of Java or in the core of Java we have our object oriented programming paradigm, and this object oriented programming paradigm is so integral to Java that it is required to be understood in even in order to write our first program which we will be writing soon. So in this lecture what we have covered was the bytecode concept of the bytecode and platform independency, how Java is going to achieve that. And in our upcoming lectures, before starting before starting our programming thing, or before writing our first program, the concept which we need to go through is about the object oriented programming. And this object oriented programming is actually the paradigm on which the language Java is based, and it is very integral to Java. So in our upcoming lecture we will be covering the object oriented programming fundamentals which are related or in context to or in reference to Java. And here is a list of references which is being used for the preparation of lecture. Hope you have enjoyed one. I will see you in the next lecture. Till then, take care. Goodbye.